Next is question number 43, which says that the minimum value of sin inverse x whole cube plus cos inverse x whole cube is equal to m. Then we have to find the value of pi cube upon m. See, we know that a plus b whole cube is equal to a cube plus b cube plus 3ab times a plus b. So let's find the value of a cube plus b cube from here. So we can write sin inverse x plus cos inverse x, that is value of a plus b here is pi by 2. So we can write it here pi by 2 taking common a plus b whole square, that is pi square by 4 minus 3 times ab, that is sin inverse x into cos inverse x can be written as pi by 2 minus sin inverse x. So this is what we get from here. So that is equal to pi by 2 multiplied with pi square upon 4 minus 3 pi by 2 multiplied with sin inverse x plus 3 times sin inverse x whole square. So this is equal to pi by 2 multiplied with pi square by 16 plus 3 times sin inverse x minus pi by 4 whole square. Now we have to find its minimum value. Its minimum value will be obtained when sin inverse x is equal to pi by 4, that is this value is equal to 0. So minimum value will be pi cube divided by 32, which means that value of m is equal to 32. So this is the answer. Next is question number 44, which says that in triangle ABC, c is equal to pi by 2, sin inverse x is equal to sin inverse ax upon c plus sin inverse bx upon c, where ABC are sides of the triangle. If the total number of different values of x is n, then we have to find the value of n raised to the power n. See, we know that sin inverse a plus sin inverse b, this is equal to sin inverse a multiplied with under root of 1 minus b square plus b times under root 1 minus a square. And it is true when a square plus b square is less than equal to 1. And in this case, it can be seen that it is less than equal to 1. So we can safely apply this formula, because here we have c square is equal to a square plus b square for right angle triangle. So we can have here sin inverse x is equal to sin inverse ax upon c into under root of 1 minus b square x square upon c square plus bx upon c into under root of 1 minus a square x square upon c square, right? So this is equal to sin inverse ax taking c square in the denominator outside. So we have here c square under root of c square minus b square a square. Similarly here bx upon c square into under root of c square minus a square x square, right? This is obtained here. Now we can directly say x is equal to ax upon c square into under root of c square minus b square x square plus bx divided by c square into under root of c square minus a square x square. So x taking common, we can say either x is equal to 0, or taking c square on the left hand side and squaring, we will have c raised to the power 4 equal to a square into c square minus b square x square plus b square into c square minus a square x square plus 2ab into under root of, multiplying these, we will get c raised to the power 4 minus a square x square c square minus b square c square x square plus a square b square x raised to the power 4. So this is what we get from here, right? So further it can be written as, here we have a square c square plus b square c square. Taking c square common, a square plus b square can be written as c square. So we have c raised to the power 4 minus 2a square b square x square, right? plus 2ab into under root of, here taking x square c square common, we will get again a square plus b square, that is c square. So we have minus c raised to the power 4 into x square plus a square b square x raised to the power 4. So these two will get cancelled. Now 2ab will also get cancelled with here 2ab. So we are left with abx square. Doing squaring on both sides, it will be equal to c4 minus c4x square plus a square b square x raised to the power 4. Now these two will also get cancelled. Now c raised to the power 4 is not equal to 0, which means that x square minus 1 is equal to 0. That is x square is equal to 1. So that which means that x is equal to plus minus 1. So we can say that we have three different values of x, that is 0, 1 and minus 1, which means that value of n is equal to 3, which means that 3 raised to the power 3, that is answer is equal to 27. Right? I hope the question is clear to you. Now let's discuss question number 45, in which we have to find the domain of the function fx. Right? So for this function to be defined, this should be greater than 0. If I take minus common, then I can say that log 4x whole square minus 5 log 4x plus 6, it should be less than 0. Taking this as t, so we will have t square minus 5t plus 6 is less than 0. That is t minus 3 into t minus 2 is less than 0. That is t, that is log 4x will go from 2 to 3. That is x will belong from 4 raised to the power 2, that is 16 up till 64. Value of a plus b will be 16 plus 64, that is 80. So answer will be 8080. Next is question number 46, in which we have to find the number of integral values of x for which it is less than 0. Now here it can be seen that in the denominator we have factorial function, which means that x minus 1 should be greater than 1, which means that x is definitely greater than 1. Right? Only then the factorial will be defined. So here we can see that if we talk about this term, then for x greater than 1, pi divided by tan inverse x, it is definitely greater than 2. Right? Which means that this first bracket is always positive for x greater than 1, which means that we are left with only this function, that is x square minus x minus 56. So this should be less than 0. Right? So we can say that x minus 8 into x plus 7, it should be less than 0, which means that x will belong from minus 7 to 8. But we have x greater than 1, so number of integral values we have to find. So the integral values will be 2, 3, 4 and so on up till 7. So we have 6 values here, which means that answer of this question will be 6. Next we have question number 47, which says that for all n belonging to n, function fnx is given and gnx is given. If fundamental period of this is t, then we have to find the value of 5t. Right. So let's firstly find the function fnx, which is equal to summation k going from 1 to n sine square x divided by, see, cos square alpha minus cos square beta, that can be written as sine square beta minus sine square alpha. We can write it as sine square 2k plus 1 divided by 2 multiplied with x minus sine square x by 2. Right? Now, we know the formula of sine square a minus sine square b. This is equal to sine of a plus b into sine of a minus b. So applying it here, we will get it equal to summation k equal to 1 to n sine square x divided by, here we will get sine of a plus b. So we will get sine of kx multiplied with sine of k plus 1 into x. Right? Now, taking one sin x outside, we can write it as sin x multiplied with summation going from k equal to 1 to n. Sin x can be written as sin of k plus 1 into x minus kx. Right? And in the denominator, we have sin kx into sin of k plus 1 into x. So this is further equal to sin x into summation of k from 1 to n. See, sin of a minus b, this is equal to sin a cos b minus cos a sin b. Right? And in the denominator we have sin kx multiplied with sin of k plus 1 into x. So this is equal to sin x multiplied with summation of k from 1 to n. And here we have cot of kx minus cot of k plus 1 into x. Right? Now, if we put k from 1 to n, so we will get it equal to sin x multiplied with cot x minus, putting here k equal to n, we will have cot of n plus 1 into x. So this is what we get from here. This is further equal to sin x. Here we can write it as cos x divided by sin x minus cos of n plus 1x divided by sin of n plus 1 into x. So cancelling the terms, we will get it equal to sin of nx divided by sin of n plus 1 into x. Right? So this is what we have obtained, fnx. Now we have to find gnx. Now gnx will be equal to multiplication of frx, where r goes from 1 to n. So solving this, we will get gnx equal to sin x divided by sin of n plus 1x. Right? Now we have to talk about f 2019x divided by g 2019x. So this will be equal to sin 2019x divided by sin x. Now we have to find its period. Its period will definitely be equal to pi. So the value of greatest integer of 5 pi, that will be equal to 15. So answer of this question is 15. Now next is question number 48, which says that fx is equal to tan inverse of this function. Then we have to find the value of secant raised to the power 5 of f of root 3 plus 1 upon 4 root 2 plus f of 1 by 2 root 2. We can rewrite fx is equal to tan inverse. See, here dividing whole by 2x. So here in the under root we will divide it by 4x square. So we have 1 upon 4x square minus 1. Right? Minus root 3 divided by, here also divided by 2x, we have 1 plus under root of 3 upon 4x square minus 3. Right? So this will be written as tan inverse under root of 1 upon 4x square minus 1 minus root 3, and in the denominator we have 1 plus, taking root 3 outside, under root of 1 upon 4x square minus 1. Right? We can write it equal to tan inverse under root of 1 upon 4x square minus 1 minus tan inverse root 3. Clear? Now we have to find the value of f of 1 by 2 root 2. So that will be equal to tan inverse. Putting it here, 1 by 2 root 2, we will get 2 minus 1, that is 1. That is tan inverse 1 minus tan inverse root 3, that is pi by 3. So that is equal to pi by 4 minus pi by 3. Similarly, finding the value of f of root 3 plus 1 divided by 4 root 2. So this will be equal to pi by 12 minus pi by 3. So we have both these values. So we can see that secant raised to the power 5. And adding these two, we will get minus pi by 3. So this will be equal to 32. So answer of this question is 32. Next is question number 49, which says that let f be a function satisfying f of 23 minus x is equal to f of 23 plus x. For all x belonging to R, if fx intersects xx is at only 3 points that are given to us, then we have to find the value of alpha plus beta plus gamma. See, if we have any function which is symmetric about x equal to 23, right, and it intersects x-axis at exactly 3 points, then it means that one of the point will definitely be x equal to 23. That is, it is intersecting x-axis at 3 points, that is 23, 23 plus lambda and 23 minus lambda. Now we have to find addition of all these three. So adding these three, we will very easily get 69. So answer of this question will be 69. Now next is question number 50, which says that if tan inverse half plus tan inverse 2 by 3x plus tan inverse 3 by 4 is equal to pi by 2, then we have to find the value of sine of pi minus 2 times tan inverse x. That is given to be equal to m by n. So we have to find m plus n. Now these can be written as tan inverse 1 by 2 plus tan inverse 3 by 4 is equal to pi by 2 minus tan inverse theta, that is equal to cot inverse theta. Right? So applying here tan inverse A plus tan inverse B, we will get 1 by 2 plus 3 by 4 divided by 1 minus 3 by 8. So this is equal to cot inverse 2 by 3x. Solving this, we will get 4 plus 6 divided by 5. So this is equal to tan inverse 2, which is equal to cot inverse 2 by 3x. Now this can be written as tan inverse 3x upon 2 if x is greater than 0. Now from the given equation, it can be seen that x should always be greater than 0, only then we will get a solution. Why? Because this value is little less than pi by 4. This is also less than pi by 4. So this value should definitely be positive, only then it can be equal to pi by 2. Right? So x is always greater than 0. So we can write it as tan inverse 3x by 2. So from here we will get value of x as 4 by 3. Right? So this is the only solution. Now let's find the value of sine of pi minus 2 times tan inverse 4 by 3. So this will be equal to sine of pi minus, see, 2 times tan inverse 4 by 3. That will be equal to pi plus tan inverse 8 by 3 divided by 1 minus 16 by 9. So these two will get cancelled. So we will get sine of, minus can be taken inside. So we will have tan inverse 24 by 7. That will be equal to sine of sine inverse 24 by 25. So this is equal to 24 upon 25, which means that m plus n will be equal to 49. So our required answer will be 4949. So this is the answer.